Hello everyone, thank you for joining me today. Let me start the presentation with a brief introduction of myself. My name is Agata, I am DevOps/cloud engineer and I work as a senior cloud consultant at the Scale Factory, which is UK-based DevOps consultancy passionate about scaling. And today I am excited to talk to you about scaling as well, but this time it will be scaling secrets management using HashiCorp Vault with a zero trust approach. And my talk will include demo at the end, so stay tuned. So let's start the presentation with the best way possible, boring history lesson about zero trust. But zero trust is not just some buzzword thrown around in security meetings, but it is a total mindset shift. Imagine your company's network as a medieval castle. The old security model assumes that once someone gets past the moat, they can freely roam the castle. Zero trust flips that on its head. No one gets automatic trust, not even the king. Everyone is verified everywhere, all the time. Back in 2010, John Kindervag, a security analyst at Forrester Research, took a look at the old school trust but verify approach and said, no, let's flip that. First verify, only then trust. He argued that organizations should never automatically trust anything, whether it is inside or outside their network. Fast forward a decade, and cyber threats have exploded. Cloud computing, remote work, and sneaky hackers have made the old model obsolete. Governments and big corporations caught on, and in 2021, the US government even issued an executive order telling federal agencies to implement zero trust security. Let's have a look at foundations of zero trust. What are rules? What are three golden rules for it? First, verify explicitly and continuously. Trust no one, authenticate everyone. Access decisions should be based on multiple factors, like identity, device security, and request context. For example, a developer on the corporate VPN still has to pass multi-factor authentication before grabbing secrets. No free passes. Second, least privileged access. Give people and systems only the access they need and nothing more. A microservice fetching a database password should only get that one secret, not the keys to the whole kingdom. Third, assume breach. Be paranoid. Monitor everything, log every action, and act like an attacker is already inside. And Vault is built to make these zero trust principles a reality. And for example, if API key leaks, Vault ensures it has a short lifespan and rotates it before any real damage happens, and we will see that in the demo section. Even as organizations adopt zero trust security models, many struggle to implement it effectively. While zero trust is about verifying and securing access at every step, organizations often fail in key areas and leave them vulnerable to breaches. Here are some of the most common pitfalls. First, hard-coded secrets code. I bet we all saw this one. Developers sometimes hard-code API keys, passwords, and other credentials directly into the source code, which is so wrong, and of course, it is bypassing zero trust principles. For example, a company stores AWS credentials in a public GitHub repository. An attacker discovers the repository, not a big challenge, there are softwares for automatic scanning of such cases, extracts the keys, and gains full control of the cloud environment, bypassing security controls. Another example of a common bad practice is overprivileged access. Without proper enforcement of least privileged access, teams often grant excessive permissions to users and services. This undermines the zero trust principle of granting access only when necessary. A database administrator retains full access to production credentials even when they don't need it regularly. And in such a case, they increase the risk of accidental leaks or intentional misuse. Next on our list is lack of visibility and auditing. Without robust auditing and logging mechanisms in place, organizations struggle to track who has accessed which secrets when, and which violates zero trust monitor everything. And imagine that a DevOps engineer accidentally uses outdated credentials, but there is no audit trail to track the incident to provide accountability. Last but not least, long-lived static credentials. Storing long-lived static credentials like hard-coded API keys or passwords creates a persistent attack surface, contrary to zero trust goals of rotating secrets regularly. And let's imagine that a SaaS provider keeps a static MySQL password for years. When a former employee's credentials are compromised, attackers gain unauthorized access long after the employee leaves. And Vault is designed to address these challenges by ensuring that zero trust model is applied consistently throughout an organization's security framework. Here are some examples how Vault helps organizations stay true to zero trust principles. First, dynamic secrets and short-lived credentials. Vault generates dynamic secrets for databases, cloud services, and other resources, ensuring credentials are short-lived and automatically rotated. This eliminates the use of long-lived static credentials and reduces attack surface. Instead of hard-coding AWS IAM keys, Vault dynamically creates short-lived credentials that expire after a set period, making it harder for attackers to use compromised keys. And we will see this example on the demo part. Second, identity-based access control. Vault enforces access policies based on identity, ensuring that only authorized users and services can access secrets. By integrating with IAM systems and using policies that adhere to least privilege principles, Vault ensures that only the minimum required access is granted. Vault supports authentication methods like OIDC and April, the latter for machine-to-machine specifically, ensuring that only verified users or services can access specific secrets and that permissions are scoped to the least privilege needed for the task. Last but not least, third, fine-grained access control and encryption as a service. Vault enforces fine-grained access control by allowing organizations to define specific policies that govern who can access which secrets and how they can be used. For example, a team might have read-only access to a certain database credentials, while another team has full access. Additionally, Vault provides encryption as a service, ensuring that sensitive data is encrypted both at rest and in transit, protecting it even if the underlying storage is compromised. As your organization grows, so does the complexity of secrets management. It can quickly become overwhelming. Think managing secrets across multiple teams, microservices, cloud environments, and still having to keep an eye on compliance and regulatory requirements. But don't worry, scaling secrets management does not have to be a nightmare. You can follow these best practices to make it as smooth as possible, and Vault will help you with it. Firstly, automate secrets lifecycle management. Forget manually rotating, revoking, or expiring secrets. Let Vault handle it for you. With Vault's dynamic secrets, you can automatically generate short-lived AWS IAM credentials instead of relying on static and potentially compromised keys. As a bonus, Vault can rotate database credentials for you, keeping everything fresh and secure without even lifting a finger. Second, leverage namespaces. Isolation is a key when managing secrets for multiple teams or services. With Vault Enterprise namespaces, you can create isolated environments for different departments, like finance, engineering, HR, and control access to secrets on a per team basis. And don't forget, namespaces help keep your tenants safe by giving you access over how each team accesses resources. Next on our list, implement high availability. Secrets management needs to be always available, especially as you scale. You can run Vault in high availability mode with multiple servers, so if one server fails, others are ready to pick up the slack. Vault's performance replication ensures that your secrets are efficiently distributed across global regions, reducing latency and speeding up authentication requests. Integrate identity and access management. You can control access like a boss with identity-based policies. With OIDC authentication, developers can authenticate using their organization's single sign-on systems. It's seamless and secure. And for your CI/CD pipelines, April authentication allows you to securely grant access to the right resources when needed. Monitor and audit. Stay on the top of who's accessing what, when, and why. You can enable detailed audit logs in Vault so you have a full record of who accessed secrets and when. Vault's audit devices capture all the details from the request to the response to give you complete transparency. And if you need real-time insights, you can set up Prometheus and Grafana dashboards to monitor Vault's health and performance at a glance. Backup and disaster recovery. Even secrets need a safety net in case something goes wrong. You can set up Vault snapshots to automatically backup encrypted secrets to a secure offsite location, ensuring you won't lose anything important. And because they're automated, you don't have to do anything here after they're set up. For the true peace of mind, use Vault Disaster Recovery Replication to maintain a standby Vault instance in another data center or cloud region. If disaster strikes, Vault can promote the standby instance to primary, keeping your secrets safe and available. So now let's see Vault in action, how it can help scaling our secrets, especially when it comes to rotating credentials and generating short-lived credentials. So I have my Vault already working. I can connect to it, and I want to work with the database. So I can set that up in cloud, but if I don't have that in cloud, I can just use Docker to provision such a database. And I will do that right now. I will create Postgres database with environment variables, with user and password. And the password will be super secure, super strong, password. My database will also be named password and username as well. I will use port forwarding here to make sure I have access to Postgres port on my local laptop. Looks like it has spin up, so now I just want to have a look if I want to connect to my database. Let's try it once again. Okay, just a typo in password. As you could see, I can connect to Vault. Okay, to the database name Vault. Cool. Let me clear that. I have Vault, I have my DB, which is Docker container. What I can do right now, what I want to do right now, I want to tell Vault to generate short-lived credentials for the database and rotate them automatically. And for that, I will use Vault write, and I have to create database config for it. After /config, I will specify database name. It can be whatever I want. Okay, a plugin is specific for PostgreSQL if you're using different database. you have to check in documentation what plugin is specifically for that. Next is role. I don't want to use long-lived static credentials, Vault and Vault password, because they're not secure to connect to my database. I want to use a role with short-lived credentials, and I have to tell Vault name of that role. You may ask, okay, but when did we create that role? It does not exist yet, but we already specify its name. Next step would be create a role. Important thing, I have to tell Vault how to connect to a database, and you know that for that I actually have to use long-lived credentials. But what Vault allows me to do is to parameterize it using this convention. However, now I have to specify values for it. These values will be not visible in configuration. Success, this is a good information because after such a write, Vault automatically checks if it can connect to database. So it means it got connected. Cool. Now, how can I check the configuration? This very analogical operation with read. I see my allowed role, I see other configuration I specify here, but I don't see username and password, which is something I wanted to achieve. This is root credentials, this is static, I don't want to display it, even for myself. Okay, now let's take care of creating that role. We know that we have to use write, but now it will be databases/roles. Now remember, this role name should match whatever we specified before, so I hope I did not make any typo. Options. Again, whatever name for config we specified, we cannot make typos here. I should actually display config above. Okay. How long do I want my credentials to live? I want to be secure, so I specified 1 hour. And now what will be the query, SQL query, which my role creation will execute. And I want a specific query because you saw I just ran the Docker container. I did not create any role inside. So what will handle role creation on Postgres side? Exactly this query. And I just allowed myself to copy and paste it because I don't want to make a typo and I don't want it to become debugging session. But what does it do? First of all, it's success, which makes me happy. But in Postgres, it just runs a query to create a role with a specific password. It will be valid until expiration, and it just grants select on all tables in schema public. And you can also add more roles, but remember to put them into the config as well with another permissions. That is how you will manage access. Let's display a read here for config once again. Yeah, you want another role with different permissions, just add it here to the config and create it here with specific query. Okay, that is how we display config. How to display role config. Also Vault read. Unfortunately, something went wrong here. I think it's missing, yeah, it was just missing S, which is a typo, but I can display this config with creation statements, credential types, and so on, but I don't see credentials themselves there, right? So how can I check that? It will be Vault read, but it will be database creds here, but for this specific role. Let's have a look. These are credentials which will live only for 1 hour. And such credential issue is called list. This list has specific ID. And we have a password and username. So let me try to connect to my Postgres database, to database Vault, when username is taken from here. Password. Cool, I'm inside the database. It works. Perfect. But now let's imagine our credentials leaked. We can say, okay, it's not a big deal. They will be valid only 1 hour. But let's imagine they just have been issued. We want to rotate it, or we're just having a demo and we want to learn how to rotate credentials ourselves without waiting for Vault. So for that purpose, we have Vault list revoke. And we have to use actually the path for crest I also used here. Sorry, actually it is path to list ID, not the role itself, because these credentials have specific list ID. Okay, all revocation operations queued successfully. So what if I want to log into the database again? I will not cheat, I will just copy and paste it. Authentication failed. This is something we want to achieve. Can I use new credentials? Yes, we can. They will be also short-lived, and I will try to log in to the database using new credentials to prove that it works. Hopefully it will. It did. Okay. We rotated the password credentials successfully. We logged in using new credentials. And now you may ask, okay, but remember you put super strong and super secure password, Vault password for user Vault. It's not secure. I don't want to have such root credentials. What can we actually do is we can rotate root credentials, but we have to do it little bit differently. It will be write database rotate root. And now, what database is that? Cool. And because I want them to be very secure again, I want to display config, and I don't want to see them. So as we spoke, root credentials are not here. Only HashiCorp knows only Vault knows at this point how to access root credentials for this specific database, which is something we wanted to achieve. So this is it for our demo. Actually, I hope it was useful. It showcased dynamic database credentials, no static passwords stored anywhere, as we saw, short-lived access, credentials expire automatically, and finally zero trust applied. Every request is authenticated and authorized. So, thank you for your attention. I hope you learned something today, and I encourage everyone to stay in touch. Cheers!